In this video, I want to compile the solution for STAT 202 Imo State University, and that's the year of 2019-2020 section. The first question says, assuming a linear relationship and y being dependent on x, determine the regression equation for the data given below, which is this. So let's draw this table. So we draw the table, and for us to get the regression line, the regression is given as y equal to a plus bx, where this is the intercept and this is the slope. So if we want to find b, if we want to find a is given as y minus bx, making a subject of the formula, and b is given as n summation xy minus summation x summation y all over n summation x squared minus summation x all squared. So it means we need to find b before a, because we need to get a before we can get b, but we don't necessarily need a before we get b. So we need to find b first. So from there, it means we need to develop a table for xy, develop a table for x squared. So this is x, and we need to get x squared. 1 squared is 1, 3 squared is 9, 6 squared is 36, 5 squared is 25. So we've developed for x squared, we develop for xy. So the next thing we need is the summation. So summation x, summation y, summation x squared, and then for summation x we have 85. For summation y we have 150. For summation xy we have 1526. For summation x squared we have 933. So we can now fix that into the formula. So what we have is that b is equal to, for us to get n is actually the number, serial number 1 2 3 4 5 6 7 8 9 10. So n is 10. So we say 10 times summation xy, and summation xy is 933. So we're going to have, I beg your pardon, summation x squared is 933, while summation y is 1526. Sorry for that. So I haven't corrected that. We have 1526 minus summation x is 85 times summation y is 150 over n is still 10 times summation x squared is 933 minus summation x all squared, which is summing x first then squaring it, which is 85 squared. So if we multiply this and this, we're going to have 15260 minus, if we multiply this and this, we'll have 12750 over this will get 9330 minus this squared will get 7225. So the next thing, if we minus this and this, we'll get 2510 over, if we minus this and this, does this from this, we'll get 2105. And if we divide that, we're going to have approximately 1.1924, 4 decimal places. All right, so the next thing is to get our a. Our a is equal to y minus bx, but we have a lot of values for y, so we take the average, which means a is equal to the average of y minus. The same thing goes with x, the many values for x, we take the average. So a is equal to summation y over n, that's the formula for average, minus b summation x over n, formula for mean. So we have that a is equal to, if we saw the summation of y is 150 over 10, that's how many they are, minus our b, we got it to be 1.1924 times summation x, we got it to be 85 over 10. So if we divide this just one decimal place, we're going to have 15 minus 1.1924 times, if we divide this by 10, we're going to have 8.5. So if we multiply 8.5 and this, we're going to get about 10.1354. So if we have 15 minus that value, we're going to have that a is equal to 4.8646. So y is equal to a plus bx can be written as y is equal to the value of a is 4.8646 plus the value of b is 1.1924, then x. That's the regression equation for that table. For the II of the question says, determine the Pearson product moment correlation coefficient for that same data above. Now, all we need to do is the Pearson is given as R equal to n summation x, y minus summation x, summation y all over square root of n summation x squared minus summation x all squared into n summation y squared minus summation y all squared. So this is the correlation. I mean, in the table we just need to add y squared also, so we can use the table. So instead of drawing the table again, we're just going to draw the table and just draw one file of table and add it as y squared. And for the y squared, we're going to get the value of 36. That's 6 squared, 8 squared, 10 squared, 12 squared, and the rest. So which means we're going to get 36, and we're going to get the next number to be 64, 100, 144, 252, and okay, 384, and 324, 400, 484, and 576. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So complete. If we sum that, we're going to get 2764. So that will be our y squared value. So coming here, we'll have that R is equal to our n is 10. 10 times the summation xy, like we used it before, is 1526 minus 85 into 150. Still the same values that we have done, we've used before. So n is 10 into let me turn and see it. That's 933. So 933 minus summation x, which is 85 all squared, then for y, which is 10 as well, 10 summation y, which is 2764 minus 150 squared. So summation y squared is this. So now if we resolve, we're going to have that this multiplied by this 1526 minus this multiplied by this, like we did it in the first one, we'll have 12750 all over square root of, if we multiply this and this, we'll have 9330 minus this squared, we're going to have about 7225. So on this other side, we'll have 2764 minus 150 squared. We're going to get 2250. So if we resolve the top, we're going to have 2510 just like we did in the first one, and then the difference is just the denominator. Here is still the same thing, 21 let me refresh myself. Okay, 2105. So 2105 times, then on this other side we're going to have 5140. So it means R, we're going to have 2510 over square root of this, multiply this will give you 10819700. So R is equal to 2510 divided by the square root of this is 3289.33, and if we divide that we have 0.7631 for decimal places. That's the correlation coefficient, that's the Pearson moment. That's how to get it. All right. The next question says, in a Fuji dancing competition, two judges scored 10 contesting couples on their performances as shown in this table. So let's draw this table, putting it in a vertical. So this is actually the table on a vertical. So it now says, calculate the Spearman rank correlation coefficient between the two judges. Now, we need to rank them. Rank A, then rank B. We can start from the lowest or we can start from the highest. So if we're to start from the highest, it means that the highest is for A is 96, and 96 appears twice, so we give him 1.5, 1.5. If he appears once, it will be 1, then the next one will be 2, then the next one will be 3. But since they are 2, we add together, divide by 2, which is 1.5, 1.5. Then it means we assume 1 and 2. The next ranking we're going to give is 3. So, which means the next thing there is 92. So we give him 3. The next one there is 90. We give him 4. The next one is 86. We give him 5. The next one is 77. We give him 6. The next one is 74. We give him 7. Then the next one is 72. We give him 8. Then the next one is 67. We give him 9. Then the next one is 60. We give him 10. So that's the 10 rankings. The next one is to rank B. The highest for B is 97. We give him 1. The next one there is 95. We give him 2. The next one there is 86, and 86 occurs twice, so we say 3.5, 3.5. So it means this is 3, this is 4. It means our next ranking will start from 5, and the 5, then the fifth one is it 48? Sorry, the 3.5 is actually on 86. 86. So after 86 we have 80, and 80 is now 3.5. So 3, 4 means this one now is 5. The next one is 73, 6. After 73 we have 6 here. The next one we're going to have is 66, which is 7. Then the next one we're going to have is 52, which is 8. After 52 we have 49, which is 9. Then we have the last one, which is the least, which is now 10. So please, you just need to be careful checking them so having done that, we can now find the difference the difference is this minus this absolute value we don't really get, even if you put the minus sign, because we're going to get d squared. The minus sign is still going to disappear when we square it. So 2, this minus this still 0.5, this minus this is 3, this minus this is 0, this minus this is left with 0.5, this minus this is minus 2, so we just write 2, this minus this is 6, this minus this is 0, this minus this should be 2, then this minus this is 1. Even if it's minus 1, when we square it, it will still 0. That's why we say absolute value. So if we square our d, here we have 4, here we have 0.25, here we have 9, here we have 0, here we have 0.25, here we have 4, here we have 36, here we have 0, here we have 4, here we have 1. So if we are to add all of them here, we're going to have 58.5. And the Spearman ranking says that if we use SP for Spearman, you can use, some textbooks will use P, I don't know, you can use anything. So you can use R, you can use P for Spearman. So the formula is 1 minus 6 summation d squared all over n into n squared minus 1. So we have 1 minus 6 is a constant times summation d squared, which is 58.5 over our n is 10, the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because there were 10 contestants that were ranked by the 2 judges. So into 10 squared minus 1, and we have 1 minus, this times this should give us 351, and then over this is 99. 99 times 10 will give us 990. So 1 minus, if this divide this, we get 0.3545. So this minus this will give us 0.645, maybe 5. So this is our Spearman ranking. The next is number 2 question. In a course of a survey, research students obtained the data in the below. So let's draw this table. So the question says, test at 5 level of significance that there is a relationship between gender and major. The first thing we need to do is we state the hypothesis. Having drawn the table, the hypothesis null. We have 2 types of hypothesis: the null hypothesis and the alternative hypothesis. The null HO says there is no difference, which means this will say that there is a relationship between gender. I mean, there's a relationship means they are the same, they are related, they are close, they are the same. That's what null hypothesis normally says. The alternative will say there is no relationship between gender and major, which means they are different, because alternative hypothesis is a hypothesis of difference. So this is the hypothesis of no difference, this is a hypothesis of difference. So once again, this will say that there is a relationship between gender and major. This will say there is no relationship between gender and major. The next thing is to state the alpha, which is significance level. What they give to us is 5% level of significance, which is 5 over 100, which gives us 0.05. The next thing is to choose appropriate test hypothesis. Appropriate test hypothesis, which one should we choose? From the table, we need to confirm whether it is actually a contingency table or not. So to confirm that it is a contingency table, we add total here, we add total here as well. So if we add all this row value, we have 34, and if we add the second row, we have 23 as the total. If we add the first column, we have 21. Add the second column, we have 22. Add this one, we have 14. If we add this total plus this total plus this total, we have 57 as well. If we add this and this, we have 57. So it is actually a contingency table, and because of that, we are going to use chi-square. And chi-square says summation observed frequency minus expected frequency all squared all over expected frequency. I is the rule, J is the column. So if you are moving this way, this is rule, first rule, second rule. This is first column, second column, third column. We don't really add the total because we are the ones that actually created the total column and row. So this is first column, second column, third column. This is first rule, second rule. So what we're given actually is the observed frequency, but we're not given the expected frequency. So we need to calculate the expected frequency before we can use this formula. And for us to get the expected frequency, it is given as row total times column total all over grand total. So the grand total is this because it's the total of the totals. So the other quarter of them all. So that's the grand total. So if we say E11, that is the meaning of IJ, rule and column. It means 1, 1 now, first rule, first column. If we say E12, it means first row, second column. If we say E21, it means second row, first column. If we say E22, second row, second column. So the first value there is for the row, the second one is for the column. So E11 means first row, first column. So we row total times column total. So first row total where is 34, then first column total is 21. So we say 34 times 21 over grand total, which is 57. E12, first row, second column, the value will be the total of the first row, which is 34, times the total of the second column, which is 22, over the grand total, which is 57. E13, because we have a third column, E13 will now be, we have the total of still 34, the total of the third column is 14, so over 57. Then we go to the second row, E21, the total of second rule is 23 times the total of the first column is 21 over 57. That's the grand total. E22 is the total is still 23 times the total of the second is 22 over 57. I need to use here E23 will be 23 times 14, total of second column times total of second row times total of third column. So second row, third column over the grand total. So having gotten the values for them, we can now use our formula that says chi-square is observed value minus expected value. In the table, the first observed value given to us was 10. 10 minus the first expected value we've got here is 12.5263 all squared over 12.5263 plus, because the formula says summation, so we need to add. So plus the next one in the table we have 14, so we have 14 minus the second one is 13.1228, so 13.1228 all squared over expected, which is 13.1228 plus the table, the next one is 10, or 10 minus the expected value of the next one is 8, 8.3588 all squared over 8.3588. So plus the next one in the table is 11. 11 minus the next one is 8.4737 all squared over 8.4737 plus in the table we have next to be 8 observed minus the next one is 8.8 So 8.8772 all squared over 8.8772. Then the last one in the table is 4. 4 minus the expected is 8 point, sorry, expected is 5.6491 all squared over 5.6491. So if we get all their values, let me use here. If you get all their values from the calculation, you'll be getting 6.3822 plus 0.7695 plus 2.6935 plus 4.5063 plus 0.7695 plus 2.7195. Then if you add all of them, it means chi-square calculated value will be 17.8405. So this is the calculated value. For us to get the tabulated value, our tabulated value for chi-square will be chi-square v, 0.05, which is the level of significance given to us. And for us to get our v, degree of freedom, it is given as the number of role minus 1 times the number of column minus 1. If we check the table, we have 2 rows only, so we have 2 minus 1 times. If you check the column, we have 1, 2, and 3. So we have 3 minus 1. This is 2 times 1, which will give us 2. So we'll see chi-square tabulated is chi-square 2, 0.05. And if we check in the table that was given to us, chi-square critical value, chi-square 2 under 0.05, 2, so 2 under 0.05, the value is 5.991. So the value is 5.991. So we compare what we calculated and what we calculated and what we tabulated, what we got from the table, what we calculated. You can see this is greater than this. Whenever calculated value is greater than the tabulated value, we reject H0 and accept H1. And whenever calculated value is less than the tabulated value, we're going to accept the H0. So in this case, the calculated value is greater than the tabulated value. So we reject H0 and accept H1. And what did H1 say? H1 said that there is no relationship between gender and major. The next question is number 3, and it is under ANOVA. So I will need to skip it and solve it as the last question, please. Okay, so we go to number 4. Number 4 says the mean number of letters delivered to the Dean's office and to the HOD's office were recorded over varying periods of time, and the summary given below. So this is the summary. We need to interpret it. It means the first n number of days, that's sample n1 is 63, n2 is 52. Mean of letters, the first mean is 48.1, the second mean is 44.6, and the third. So let's interpret it. Let us interpret it. The first n1 is actually 63, then n2 is 52, then the first mean is 48.1 and the second mean is 44.6, and the standard deviation first one is 6.24, second one is 8.56. So 6.24 and second one is 8.56. So having gotten that, what's the question? The question says, test at 10% level of significance that the proportion of left-handed pupils in school. Sorry, I'm reading the wrong question. The question says, is there significant difference between the two means given equal population variances? So that's the question. Is there significant difference between the two means given? So it means the first null hypothesis will state that there is no difference. Mu1 is equal to mu2. The alternative will now say that there is difference. They are not equal. So which means this is a two-tailed test. This is a two-tailed test. Alpha level, that is 0.5, which means we're going to divide it into two because it is two-tailed test, which is 0.025. The next thing is to choose the level of the test that we're going to use. If you check, you notice that the value of our sample size is high. So because of that, we're going to use z-test. And z is given us for two population. We have x bar 1 minus x bar 2 all over square root of first standard sigma 1 over n1 plus sigma 2 over n2. So if we put the values, the first one is 48.1 minus 44.6 over square root of the first standard deviation. We'll square it, that's the variance. So we're going to have 6.24 squared over n1 is 63 over 63, plus the second one is 8.56 squared over the next one is n2 52, and when we resolve all of that, we're going to get 3.775 as our z calculated. The next thing is to calculate our z tabulated, which is our z 0.025, and the value from the table z 0.025, z critical z 0.025 is 1.960. So 1.96 or 1.960. We compare two of them. This is greater than this, and whenever calculated value is greater than tabulated value, we reject h0. So we say, since z calculated is greater than z tabulated, we reject h0 and accept h1, and therefore conclude that mu1 is not equal to mu2. That's how to write the conclusion. So the number 5 question says, given the data below, which is this, test at 10% level of significance that the proportion of left-handed students in school 1 is significantly less than the proportion of left-handed pupils in school 2. So for us to do that, we'll break down what is given to us. Number of pupils, that's n1 is 520, n2 is 320. Population, that's proportion of the first population is 0.284, then that of the second population is this. So what we need to do is, the first population is 520, the second population is 320, the first proportion is 0.284, then the second population is 0.341. So remember that for us to get P, P is actually given as, okay, let's just go straight to the point and say, and use the other formula instead of combining. Let's just go straight and use the other formula, because there are two formulas you can use. We have that Z is equal to P1 minus P2 over square root of P1 into 1 minus P1, which is Q. Q is given as 1 minus P1 over N1 plus P2 into 1 minus P2, that's Q, over N2. If we fix in the value, our P1 is 0.284 minus our P2 is 0.341 all over square root of our P1 is 0.284 into, if we say 1 minus 0.284, what we'll have is 0.716 over this one is 520, then plus, let me write it down here, what is supposed to be here, let me write it here because of space. So there for P2 we have 0.341 minus, sorry, into 1 minus 0.341, which is, let me still write it, 1 minus 0.3, let's just write the value. The value will be 0.659, so 0.659. So the z will be, if we calculate this, on top we'll have 0.057 all over square root of, if we multiply this, we'll have 0.00039, then plus over here, if we multiply, we'll have 0.00109. So if we add this and this, we're going to have 0.033, and if we divide that, we'll have 1.7272. so our z calculated is 1.72727272. so our z tabulated is z 0.0. From the question, we are to test whether there is a significant difference between the first proportion and the second proportion. The first thing we ought to have done was to state the hypothesis. So if we state the hypothesis, the first one will say that the first proportion is the same as the second proportion, and the H1 will say that the first proportion is not the same as the second proportion. So two-tail test, alpha will be 10% level of significance, which is 0.01, and because it is two-tail test, so we divide it into 2, alpha over 2, which will be 0.005. So it means 0.005. So if we check the value for 0.005, z 0.005, we'll have 2.575. 2.575. If we compare this, you see this is less than this. So our conclusion will say, since z calculated is less than z tabulated, we accept H0 and conclude that the population of left-handed people, that there is no difference between the two proportions. The number 6 question says the completion times in seconds in a physics experiment recorded by 15 different students are given as all these values and this. So determine at 95% confidence interval for the completion time this of the experiment of the result. The first thing we need to do is to put this in a table. It will help us to calculate easier. The reason is because confidence interval, 95% confidence interval is 1 minus 0.95, which will give us 0.05. And because confidence interval is always alpha over 2, we have 0.025. If we divide it into 2, 0.025. So the formula for confidence interval is given as x bar plus or minus, since it is small number t, 0.025. The level degree of freedom is n minus 1, then we have standard deviation over square root of sample size. Now we're not given the standard deviation, we're not given the mean, the sample mean, but we're given the values. So we need to create and calculate for our sample mean and then the standard deviation. So this, let's write down the values. So having written the values down, we now calculate our mean, and mean is given as summation x over n. If we add all of these values, we're going to get 910.1, and all of them are 15. So we'll have 910 over 15, 910.1 over 15. And if we divide that, we have that our mean is 60.674. So, 60.6733. Let's just use that, 4 decimal places. So, now we need to find our standard deviation. Standard deviation is given as square root of summation x minus x bar all squared over n minus 1. So what we need to do is we do every x minus the mean, then we square it. For example, so 62 minus this will give us 1.3267. If we square it, we'll have 1.7601. This minus the mean will give us 0.7267. If we square this, we'll get 0.5281, so and so on. So if we get x minus x bar squared, that is what they will all look like. And if we are to add all of them, we'll have 11.3095, which is exactly what we needed here. It means that our x is given as square root summation this is 11.3095 divided by our n is 15, so 15 minus 1. So it means our standard deviation is square root of, if we divide this by 14, we're going to get 0.8988, and square root of that is 0.89, sorry, 0.87, sorry, square root of 0.8078. So square root of that will be this, 8. So now that we've gotten our standard deviation, we can now make use of our formula. X bar, which we got 60, plus or minus, sorry, 60.6733, plus or minus the value t, 0.025, under 15 minus 1 is 14, under 14. So we check on the table. T, 0.025 under 14 is 2.15. So we have 2.15 into our standard deviation is 0.8988 over n is 15. So square root of 15. So if we resolve the bracket first, 60.6733 plus or minus 2.15. If we resolve the bracket first, we're going to get 0.2321. If we multiply it with this, we'll have 0.4990. So if we have 60.6733 minus 0.4990, what we're going to have is 60.1743. If we now say 60.6733, that's plus or minus. If we now add, we've done the minus, now the plus. If we now add 0.4990, what we're going to have is 61.172 33. So our answer is the minus first 0.1743, comma 61.17233. So that is the confidence interval. So let's go back to the question number 3 that we skipped and said we're going to do it at the end. It says, given the ratings of 5 different machine plugs below, can the claim that the machine plugs are different in performances justified? This is it. So we need to draw this table and then we state which is this. So this is the table and we state the null hypothesis. The null hypothesis will say that all of them are the same, their performances. So mu1 is equal to mu2 is equal to mu3 is equal to mu4. And the alternative will say that mu1 is not equal to mu2, all their means and all their performances are not the same. So level of significance is 5%, which is 0.05. So the next thing we have to do now is to first of all find the total we choose. For us to choose the test we use, this is the Fisher test or the F test. So the F test, we need to calculate, we add all of this. If we add, so we call it summation X, the individual, we add them together. If we add this row, we're going to get 34. If we add this row, we're going to get 22. Add this one, we're going to get 24. Add this one, we're going to get 21. The next thing we need to do is to get the square of each of them. The squared. This squared plus 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 this squared. What we're going to have is 182. Then this squared plus 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 this square, what we're going to get is 84. Then the same here we'll get 104. The same here we'll get 20. So that is 71. Sorry, 71. Here is 21. So here is 71. So the next thing we need to do is to get the total sum of squared, TSS. And for us to get that, we get it by saying summation x squared n minus summation x squared over n, or use capital letter anyone. So this is giving us, this is, if you add all of this, you are going to get 441. If you add all of this, you are going to get 101. So which will be 441 minus 101 squared over, if you count all of this, 1, 2, 3, 4, they are 28 in number. So we say n is 28. So we say divided by 28. So it means TSS, total sum of squared, will be equal to 441 minus, if you resolve this, you get 364.3214, and the value is 76.6786. So that's the total sum of squared. The next is to get the treatment sum of squared. Treatment sum of squared is given as summation x1 squared over n1 plus summation x2 squared over n2 plus summation x3 squared over n3 plus summation x4 squared over n4 minus this correction factor, so which is summation x all squared over n. So if we resolve this here, it means we square each of these, which is 34 squared, 22 squared, this, they are squared. So what we have is 34 squared plus 22 squared plus 24 squared plus 21 squared. Since all of them have equal number 7, So all of them is 7, 7, 7. So divide by 7 minus the value we got here is 364.3214. So if we resolve this area, we'll get 379.57 minus 364.3214. So the value we'll get as that will be 15.2436. So we need to turn. So okay, let's see if we can get the error sum of squared. For us to get error sum of squared, it is total sum of squared minus treatment sum of squared, which will give us the total sum of squared that we got was 76.6786 minus the treatment, which is 15.2436, and that will give us about 61, yeah, 61.435. So as the error, so we need to draw the ANOVA. So if we sketch the ANOVA table, we have source of variation, degree of freedom, then we can have a sum of squared, then mean squared, and we can now have our F ratio. If we have the treatment sum of squared, what we calculated from there was 15.2436. Then for error sum of squared, sorry, let's just say error. Here we can see treatment. Here we just see error. So it's that it captures everything. Its sum of square, error sum of square was 61.435. So the treatment, how to get the degree of freedom, is the number of rows that you have minus 1, which is 1, 2, 3, 4, 5, 6, 7. 7 minus 1 will give you 6. So the degree of freedom for treatment there, 6. How we get this is how we get for error is the total number, which is 28, minus the rows that we have, 28 minus 4. We have 4 rows. 28 minus 4 will give us 24. I beg your pardon. How to get this is total number n minus the row. So the row is 7. So 28 minus 7 will give us 21. And if we add 2 of them, we can get that the total is 27. So if you add this and this, it's 27. So another way to get this is by saying n minus 1. So that's a formula, another formula to get this, n minus 1, which is 28 minus 1, 27. Then the mean square here, for us to get here, is this divided by this. So for us to get this, we actually do this divided by this. It will give us this. And 15 points, this divided by 6 will give us 2.5406. 61 point, this divided by 21 will give us about, so this divided by this will give us 2.9255. So for us to get our F ratio or F calculated, it will be equal to this divided by this. So 2.5406 divided by 2.9255, which will give us 0.8684. So for us to get our F tabulated, it will be F, the question says, let's see the level of significance. The level of significance for the question is not really stated. So we're going to use 5%. So since it's not really stated, we use 5%. So what we'll do is F, the 6, 21. So 6 under 21 under 0.05. So we check the table. 621 F ratio, that's F calculated, F critical, 621. So 621, 0.05, that is 2.57. 2.57. So if we compare both of them, you see this is less than this. So since the calculated is less than the tabulated, we accept H naught and conclude that the performance of the machines, they are the same. Do well to like my video and also subscribe to my channel. Thank you.